Well, we're going to get a little more practice with U sub today, and I've got a special little treat, maybe a little excitement in our U sub today, so stay tuned. All right, let's dive into one warm-up practice here with our U substitution. Now, you might be thinking, do I need U substitution? Let's kind of just talk about some common mistakes. First of all, are you allowed to take this x and multiply it into this function? All right, I heard you, you said no, that's excellent. And of course that's a no, because this says you have to raise it to the third power. In order of operations, say you would have to cube that out and then multiply by x. And nobody really in their right mind wants to do that unless we really have to. So our goal is to now try U substitution. Who is a function sitting inside somebody? Well, clearly, there's parentheses there, so that's my function inside somebody. So I'm going to say u is equal to x squared plus 1, du equals 2x dx. So I get du over 2x equals dx. Here's my u, now we'll substitute. So I have x, that junk became u to the third, and in place of dx, I'm putting du over 2x. All right, now the bounds. Don't forget we need u bounds. So if x equals 0, we'll start with our lower bound. I get u equals 0 squared plus 1, u equals 1. If x equals 1, carefully plug it in, I get u equals 1 squared plus 1, which of course is 2. Okay, now I have a whole function, those x's cancel in terms of u, and notice, where is that 2 sitting? Too many of us keep pulling it out as a 2. It is actually a 1/2 from 1 to 2 of u cubed du. All right, now the nice easy integrating part. I'm going to get u to the 4th over 4 from 1 to 2. I'm going to leave this 1/2 outside and mess around with that later. So I've got 1/2. 2 to the 4th is 16 over 4 is 4, minus 1 to the 4th over 4. And I'm going to call that 16 to the 4th. So I've got 1/2 times 15 over 4. I get a nice 15 over 8. Okay, and my goal is that you felt pretty good about that. Hopefully that's a nice review problem from yesterday. All right, our next example I like to call tricky. There's a little sneaky part to this one. Now, let's talk some common sense. Can you take this x and distribute it through? Is that a legal mathematical move? All right, good answer. The answer, of course, is no, because this is to the cubed root of this function. You can't just put somebody inside of it for fun. That doesn't work that way. All right, so I can't distribute. So I have to use u sub, and the other big hunch that it's u sub is that you have somebody inside something. All right, so common sense tells me let u equal x minus 4. All right, let's do our thing. We know du is equal to 1 dx, and I can go ahead and substitute that into dx. So I get the integral of x cubed root of u du. Now, do you notice a little problem? All right, are you allowed to pull this x out? All right, and I'm sure you said no, that's the correct answer. You can only pull things out if they are constants, meaning they are numbers. You cannot pull functions outside, only numbers. All right, so I can't pull that out. Well, I can't integrate it because this says I can only integrate the letter u. I can't integrate with an x, so we must have done the whole thing wrong. No, believe it or not, we didn't do it wrong. It's just a little sneaky. So here's what we do, and this is what we want to star in our notebook here. Okay, you need to go back sometimes and use the u. All right, now what do I mean by that? All right, well, like I said, let's start, let's get it down, and now let's go use it. So let's rewrite down what u is. U equals x minus 4. Could you solve this equation for x? Well, sure, you could say u plus 4 is equal to x. So now you can use like a double substitution. You can take this and substitute it into x. So I'm going to get the integral of u plus 4 times u to the 1/3 du. Now you have one function to integrate in terms of u. Do you see how tricky that was? All right, so that's going to happen sometimes now and then. Go with your gut. You probably did u substitution right. We just got to watch this one tricky step. All right, now, I certainly can't integrate this until I clean it up. Remember, I can only have one term to a variable, so I'm just going to distribute this through. I'm going to call this 3/3. When I multiply, I add exponents. So I get u to the 4/3 plus 4u to the 1/3 du. And now I've got a real nice integral. I can say that's u. Remember, I'm going to add 3 over 3, so u to the 7/3 times 3/7 plus, I'm going to add 3 over 3, u to the 4/3 times 3/4 plus c. And lastly, don't forget to substitute that u back in. I apologize, I think that should be 3/7. So I'm going to say 3/7, what was that u? X minus 4 to the 7/3 plus 3 times x minus 4 to the 4/3 plus c. Crazy. Are you ready for another one? All right, this time we have, can you remember the name of this integral? When it has bounds, we call that a definite integral. All right, so we have the definite integral from 1 to 5 of x divided by square root of 2x minus 1. All right, why don't you pause this one, go as far as you can. My guess is you're going to need tricky u sub, so good luck, and go as far as you can and then turn it back on. All right, so maybe I turned it on too soon for you, maybe not. Here's my u, my du. I substituted that in. I notice I'm stuck. I've got tricky u sub. So now I got to go back and figure out what this x could be. So I'm going to use my u. Said u plus 1 equals 2x. Divide the 2 over. U plus 1 divided by 2 equals dx. Because there's one term on the bottom, I just made like a beaver and split. And now I'm going to substitute that back in carefully. So I'm going to say this is the integral. In place of that x, I'm putting u over 2 plus 1/2 all over the square root of u, and then du over 2. Okay? And now I know it looks hideous, but we're going to clean that up real nice. Let's go get our u bounds. So I think the first bound, oh, sugar, I don't remember, was 1 and 5. Okay. So if x equals 1, if I plug that in, I get u equals 2 minus 1. And if x equals 5, I get u equals 10 minus 1 is 9. Okay, now, let's clean this puppy up. This 2 on the bottom is really like multiplying by a half. So I'm going to pull out the 1/2, and I've got from 1 to 9 of u over 2 plus 1 over 2 square root of u. All right, and that's just a little complex fraction. I can multiply both the top and bottom by 2. So I get 1/2 the integral 1 to 9. When I multiply the top by 2, I get u plus 1 all over 2 radical u du. And then I'm going to pull this 2 out again. So if I pull that outside, I am now getting 1/4 the integral from 1 to 9 of u plus 1 over radical u du. All right, now not the prettiest integral, but we can do it. Again, there's one term on the bottom, so I'm going to split. I'm going to say this is u over u to the 1/2 plus 1 over u to the 1/2. So I'm getting 1/4 the integral 1 to 9. u to the 2 over 2 minus 1 over 2 is u to the 1/2 plus u to the negative 1/2 du. All right, so lots of small steps there. Now, this is easy as pie here. Let's just integrate u to the 3/2 times 2/3. This is going to be u to the 1/2 times 2. I've got a nice 1 to 9. Now again, I'm going to leave that 1/4 out front of all this nonsense because that's just getting a little too confusing. So I'm going to go 1/4. Carefully plug this 9 in. So I've got 2/3. The square root of 9 is 3. 3 cubed is 27. Plus 2 times the square root of 9 is 3. I have all that minus. If I plug a 1 in, it's just 2/3 plus 2, which I'm going to call that 6/3. So let's see, I have 1/4 times 9, that's a 9, so that's 18 plus 6 is 24 minus, let's see, 2/3 plus 6/3 is 8/3, so 9 minus 8/3. Love all this mental math. And I gotta scroll up here. Let's see, I'm going to call this, if I multiply this by 3, that's going to get me 72/3 minus 8/3, so I have 1/4 times 64/3, which gets me 64/12, or what does that reduce to? 16 over 3. Whew. And who doesn't love a little tricky u sub? All right, well, we've got a fantastic one to end the night with here. We've got the definite integral, because it has bounds, from 1 to 9, of 1 over the square root of x times 1 plus the square root of x squared. All right, now, let's just talk about what our gut might be saying. Can you take this radical x and distribute it? No way, Jose. That's because this is being squared. Okay, so if you're dying to, you could FOIL that out and multiply that through. Or we could do u sub because we have a function inside of a function. So I'm going to go with my u sub. U is equal to 1 plus the square root of x. And of course, I'm going to call that x to the 1/2. All right, let's go get our du. So I'm going to get 1/2 x to the negative 1/2 dx. Okay, now I think you're crazy if you try to solve for that without cleaning it up. Du equals 1 over 2 radical x dx. All right, now, does anybody like to divide by fractions? No. So remember, multiply both sides by the reciprocal. Then you don't have to deal with fractions. Okay, so those cancel. So I've got 2 radical x du equals dx. Let's substitute that in there. So I'm going to go, now don't use that 1 and 9 anymore, 1 over the square root of x times u squared. And in place of dx, we're putting 2 radical x du. Now look how beautiful that is. This radical x can cancel with this radical x. This 2 is not in the denominator, so I'm going to pull it out as a positive 2, 1 over u squared du. And let's go get our bounds. I need u bounds. These bounds, I know go with x because those bounds are with the dx. So I need to go get u bounds. U equals 1 plus the square root of x. If x is 9, I get 1 plus 3, so I get an upper bound of 4. If x is 1, I get 1 plus 1, I get a lower bound of 2. All right, nice little term to integrate. Again, I'm going to call this u to the negative 2. So I get u to the add 1 is negative 1 divided by 1 from 2 to 4. And again, don't forget you have that lovely 2 out front. I think you're crazy if you're not cleaning this up first. I'm saying this is 2 times negative 1 over u from 2 to 4. So I get 2 times negative 1 over 4 minus negative 1 over 2. So I know it's going to turn to a plus. And if I want a denominator of 4, I'm going to call that 2/4. So I get 2 times 1/4 plus 2/4 is 1/4 for a total of 2/4 or 1/2. All right, so that was not a tricky u sub. It did end up canceling. It was just kind of a rather ugly u sub problem because of this term here. But remember, multiply by the reciprocal and things should go nice and smooth. Well, believe it or not, I think that's going to do it for us tonight. Have a great night, and we look forward to some great practice tomorrow.